Hi everyone, we have got a problem here. I have some sets of Uno cards and I have been asked to find a card with number 7 in it. I have been told that these cards have been arranged in ascending order, which means the card here is the smallest card and it keeps on increasing, and the card at the end is the largest card. And I am allowed to check any one card at a time and see if it's a card with number 7 or not. So I need to find it with minimum number of checks. So what am I going to do now? I am going to apply a binary search. So let's understand what this binary search is, along with explanation, theory, programming and time space analysis. And I have also given the timestamp for all these segments so that you can skip to your favorite segment. Alright then, so here are the cards I have arranged in ascending order starting from here to here, which means this is the smallest card and this is the largest card, and I don't know where the card number 7 is. So let's apply binary search. So what does binary search says? It says that binary search is a searching algorithm which divides the given array into half at each iteration. So how are we doing that? Let's assume this card as an array. So now the range of search is an entire array. So we need to find the midpoint of our array, which means the mid card. So what is the mid card here? Let's go from extreme sides. So this is the mid card because it is equidistant from the left as well as the right. So let's check what's the mid card. It's 4. Okay. Unfortunately, this is not equal to 7, but don't be sad, we have got many information, such as since this card is 4, all the card on the left of this is less than 4, right? Because it is sorted. So now we want 7. So we don't have to concentrate on the cards which are on the left. We have to concentrate only on the card which are on the right. So I am discarding all the cards to the left of 4. You just saw what happened, right? At each iteration we are dividing the array by 2, which means we are halving the array. So now I am left with only these 3 cards, right? On the right of the card 4. So now this is my range of search. So now let's apply binary search here. So let's check the midpoint. Ta-da! This is the card which we needed. You just saw what happened, right? In just 2 checks we were able to find out my card which I had to find. So if we had to apply a linear search, we had to come from here to here, which would have taken 6 checks at worst case. So this is how binary search is optimizing the search algorithm. Alright, so let's understand what binary search is in theoretical terms. So binary search is a searching algorithm used in a sorted array by repeatedly dividing the search interval in half. So if you don't understand, it's okay. Let's understand in simple steps. So what do you have to do? Let's say you have given an array which is sorted and have been asked to find a number. So what do? Begin with the mid element of the whole array as a search key. So you have given an array, so find out the mid element, like how we found out a card with number 4 on it. So if the value of search key is equal to the item, then it's well and good, return the index of the search key. If not, so then you have to find the relation between the search key and that element. Okay, so if the value of search key is less than the item, narrow the interval to the lower half, which means go to the left half of the array, else go to the right half of the array. So then once you go to left or right half, repeat the same algorithm. So now let's understand in a given programming question. So here we have been asked to find the position of given element target 11 in the given array. So you can see this array is sorted in increasing order, and I will note it down as this, with the index starting from 0 to 7. So now let's take 2 pointers. One is called start, one is called end. So please remember, this is very important. Okay, so start, it reflects the starting index and end reflects the ending index. Since the size is 8, so the index starts from 0 to 7. So my start is 0, my end is 7, which means my area of search or the range of search is an entire array. So now what I have to do, I have to find the mid element. So how do I find the mid element? We have a formula which is start plus end divided by 2, which means the mid element, right? So here 7 plus 0 divided by 2, which is 3.5, but we have to go with an integer value which is 3. So index 3 has an element 8. Is it equal to 11? No, false. So now we need to get the relation between 8 and 11, okay, which means array of mid and target. What is the relation? So here the relation is target is greater than array of mid, which is 11 is greater than 8. So we have to concentrate on the right half of the array or the upper half. So now my area under search becomes here, this one, right? So this would be my area under search. So this would be my area under search. So now my start and end will change because this is no more my area under search. So now let's define new start, because my end remains same, because previous also it had the same one, now also it has the same element at the end, but my start has been changed. So start earlier it was 0, now it has gone to 4. So now let's see what is the midpoint of this sub array. So if you see, mid is equal to start plus end divided by 2, which is 4 plus 7 divided by 2, which is 11 by 2, 5.5. Since it's an integer, we go with 5. So now what is array of 5? It is 11. Ta-da! So hence we have got this element which we wanted to search. So just by 2 checks we have got the binary search result. So now let's jump on to coding and understand how to code it and understand time and space complexity. Alright, so let's understand how to implement a binary search in Java. So I have defined a public class called binary search. Inside that I have defined a main method. So this is the method from where the execution would start, and this is the default method. So now let me define an array to which the binary search has to be implemented. So let me define an array which is called input is equal to new int of, let's say, let me define something 1 3 5 7 9 12 15 16, right? So I'm defining it randomly. Okay, so here this array is sorted, right? So now I need to give int target equal to which shall we find? We will find the element 15. Is that fine? Let's get the index of element 15. So now let me define a method here which is a private integer binary search. Get binary search, okay? Else it will be a constructor. Yeah, so here this is the method where actual logic is happening. Okay, so here I am taking first argument as my input array and second argument as a target. Okay, so I will take that. Then what I am going to return? I am going to return the index at which this element is found. So now let me call this method. So let me do it static, because static method will be called from the static itself. Get binary search. Here I will be supplying input as well as target. Okay, let me format the document here. Okay, so from here let's understand what's happening here. So I have got my input array. So this is my input array which is sorted, and I need to find the target 15. I need to get the index at which 15 is present. So now, as you remember, we need to have 2 pointers at the left and right. So let me give left, which means let's say low is the left. Okay, or let me do start, it will be easy to understand. Okay, int end. So what is the end? End is the index of the last element, which is, because input is an array, right? So here what I have done, I have given my starting index as 0 and ending as length minus 1, because the length of this array is 8. So the index starts from 0 to 7. So the end index is 7, which is nothing but length minus 1. Now what I need to do, so I will be pushing my start pointer towards right, while I'll be pulling my end pointer towards left. I don't want start and end pointers to overlap. So what I'm going to do is while start is less than end. Okay, so all this logic shall happen when they have not collided or coincided with each other. If they are coinciding, then we have not found the any element. So then what I'm going to do, I am going to define a mid. So how did we define mid? Start plus end divided by 2. So this is the formula that I will be using to define a mid, right? So now what I am going to do, if input of mid, okay, is equal to target, which means I'm checking if the mid element is equal to target, right? So that's what we did. When I was doing it practical using Uno cards, I have got the mid element as 4, right? So if it is that one, then it is very good, right? But if not, okay, so if it is that one, then return mid, okay? So else if, okay, so else if I check, what is the relation between target and input of mid. If input of mid, okay, so we got to know that mid element is not equal to target. So let's see if mid element, let's say target is greater than mid element, which was in our case we have got 7, right? So what I will do, I will push the start to mid plus 1, right? Because I don't want the start to be 0. Now I'm pushing start to mid plus 1, right? So that's what I'm doing. So else what I'm going to do, else what can happen, what is the situation? Else the target is less than input, right? The target is less than input, which means we need to concentrate on the left half of array, which means in that case end would be mid minus 1, right? Here either mid plus 1 or mid minus 1. So let's format document. Let's say if we didn't find any element, which means start and end pointers are coinciding with each other, then obviously there is no element found, so I return minus 1, right? So this is how actually the binary search works. So here I can also give less than or equal to, because it's okay if they are touching, but they shall not coincide or cross each other. So let me just print it. So to print it, what I'm using is system.out.println format document. So let me run this. Alright, yes, 6. So I got the answer as 6. So let's understand, let's see where is the target is present. 0, 1, 2, 3, 4, 5, 6, right? So this is how. And now let me search the one which is not present, 353. It's not present, right? So I should be getting minus 1 as an answer. So this is how we perform binary search. And if you see the time and space complexity, here time complexity has been drastically optimized by OFN from linear search to OF LogN, because here at each iteration we are dividing the array into 2 halves and focusing on either left or right side. And space complexity is constant because we are not using any additional space. So that's all about this video. I hope you enjoyed it. Please do let me know how did you feel and if it was helpful to you, and if so, please like, share and subscribe. Share it with your friends and everyone whom you think will be useful. Meet you in the next one. Thank you and take care.